This video is about the electrical wiring of a point. The bit of the point that causes a lot of confusion is this part, the frog. I might mention that points are also sometimes called turnouts, or by the Americans switches. For the engine to move, we need a positive rail and we need a negative rail. Now the problem is the frog, because if the train is going to go up this line, then this rail here needs to be positive. But if the train is going straight on along this line, then this rail needs to be negative, but the two join together. Now there's several ways to overcome this, and on some points this part of the frog is made out of plastic, and then you can keep the polarities separate. On others, the rails join together. Now there is an advantage to them both being joined together, and that is because the wheels of the locomotive have got to touch the rails, and between here and the plastic part, that wheel doesn't have any electricity to pick up. With pico points, they call the points where they have a plastic part to the frog insul frog, and where the two join together they call them electro frog. And the newer ones, because they probably got fed up of having to make two identical points that just had a little bit of plastic as a difference, they're called unifrog. And those points you can wire as either this part's metal, but it can be isolated. If this was an electrofrog, which means that these two rails are connected together, all made out of metal, then what you're going to need to do is to make it negative if the train's coming along here and positive if it's coming along here. And the way that these work is that the point blades, they make an electrical contact with this is called a stop rail. So when this point blade touches that, it feeds a positive all the way along here, and it'll make both of these rails positive, so the train can travel along here. If there's a train standing here on this siding, both the rails will be at positive, and so that train will be unable to move. Similarly, if the point blade goes over here and joins onto here, that's going to make the whole of the frog negative. And then you've got these two lines, both at negative, so no train can move along there, but you've got a positive and negative, so the train can move along this way, which is what you want. There are two slight problems using the point blades to make electrical contact. The first problem is, what if you get a lot of dirt in there and then it's not going to conduct properly? And you might sometimes have had a siding with an engine standing on there and an engine standing on the other line, and when you try to make one engine move, you find that they both move. And what's actually happening there is that it isn't making any contact, and so the positive rail is feeding through one engine and that's moving, and then via the frog, this is more negative than the positive rail there, then the other engine moves. So in other words, if these don't make contact, both engines move together. The other problem is, if both of these rails are negative, when the engine comes along here, there's a small chance that its metal wheel can short between the two, and you can short the model railway out. Right, so there is a solution to this. The solution is that you make a break in that rail, and you electrically connect that point blade to that rail, and this point blade to that rail. So this is always positive, that's always negative, and then you can't get this shorting problem to switch the polarity of the frog. So what you need to do is have for example, a contact on the point motor, and then so the contact works like a switch. And if you take one wire from the positive and one wire, well, that's the positive, the other one was the negative, then as the point motor goes, this is going to change between positive and negative, and you can wire this to the frog. And then you're not relying on the point blades making contact, and so it should be it should be a lot more reliable. I'll just mention this, that I've always found that with double O gauge points, there's not really very often a problem, but with N gauge points, then I found that the point blades, because of the small size of it, they're a lot less reliable at making contact, and you must have them absolutely flat. And if there's the slightest bend in the vertical plane, then they don't work very well. That bend can be too small to notice. It doesn't upset the engine going across. Another reason that you might want to make these brakes and bond the point blades to the stock rails is if you're using a servo motor and you want to switch the frog, because then what you can do is use a double pole switch. You've got one pole that switches the frog and the other pole of the same switch you can use as an on-off to make the servo motor change. Now, because the servo motor makes the point blades move slowly, what you might find is when you throw the switch, the polarity on here changes before the point blades moved away from the stock rail, and you're going to get a short circuit. But if these have the brakes here, you can't get the short circuit because they don't change polarity. If you don't want to make these brakes and bond these rails together, and you want to use a servo motor and you want to switch the frog, another way is to switch the frog with a micro switch. This is a micro switch, and it's got a spring-loaded arm, so when the servo arm presses against it, it changes the switch, just like an on-off switch. There's a spring in this which makes it go back when the arm moves away. So that terminal would go to the purple wire, that to the red, and that to the black. Suppose you've got a passing loop with two electrofrog points, and you've got a connection positive and a connection negative. Now you can have a problem because when the point changes, if a point changes off this line to go on the loop, then that's going to set this to the frog is all going to be positive. But if the other point is set in the opposite direction, then it is going to switch all the frog to negative. And you can see what's going to happen. You're going to have a short circuit because the positive and negative are going to join together. Now it's quite easy to get around this. What you need to do is put in insulated rail brakes on this rail, on both of the rails, and then these don't connect together. Generally, if you're using electrofrog points, the simplest thing to do is immediately after the frog, put in the insulated brakes. You don't need these in the middle then. Put in the insulated brakes there. Now, the problem is now, you can't get a short, but there's no electricity to these centre wires. Well, that's quite easily overcome. You can take a wire from there to here, and a wire from here to here. Now, if this is a DC model railway, you might want to stop the trains, in which case you're going to put an on-off switch in both of these wires. But if it's DCC, then this is a normal wiring and you leave these rails live all the time. Now an explanation of Insulfrog points. This point blade connects to this rail here, and this point blade connects to this rail here. So this means if the point blade's set to touch this stock rail then it will feed the voltage all the way along here and the train will move. But this point blade isn't touching the stop rail, so there'll be no electricity in here. So if a train is standing on this line, it won't be able to move. If the point blade changes over, the same thing happens in reverse. This rail is connected all the way through to here, and this will be at negative, this one will be at positive, and the engine will move. This point blade isn't making contact with there, so this will have no electricity on it. A train standing here cannot move. Pico and Hornby points are wired in this way. Some points, such as K2, there's a switch underneath and you have the choice. So it can either be wired as I've just described, or this can be permanently connected to this rail, and this can be permanently connected to that rail, which means that the trains move on both tracks. If your aim is to make your model railway as reliable as possible, use electrofrog points. The wheels have more contact with the rails. Modify the point blades to prevent potential shorts. Also, if you switch the polarity of the frog with contacts, you will get better electrical continuity than using the point blades.